Hello. So, in this lecture of this series, I want to talk about differentiation and the first principle. So, it's going to be a very basic introduction to differentiation. So, let's see. So, first principle and differentiation. So, what is differentiation? So as you remember in the last topic, we learned about an idea ki what is about what is slope. We tried to write ki for two given points, slope of the line is y2 minus y1 upon x2 minus x1. So what is this? It is change in y by change in x. It is change in y. So for this point x2 y2 and for this point x1 y1. So this value was change in y, y2 minus y1. This value was change in x, y x2 minus x1. And this gave us the idea about the tan of the theta. It gave us the idea about the tan of the theta. So it gave us the idea about the direction. So let's continue with that idea in mind, and let's talk about some generic function. So let's say we have this function, and what we want to do, let's say I want to find tangent at this point. So oh, and by that we will define differentiation actually. So let's talk about this point x on the curve y is equal to fx. So I can mark now my y coordinate as y. So I can have a general notation like x comma y. Since if you have some idea about functions, so y is equal to sine x, or y is equal to x, yeah, y is equal to any other function of x. It's just a we put a value of x, we get a unique value of y. So I can say with this definition y is also equal to fx, so this height is also equal to fx. So this point can also be written as x comma fx. And what I want to do in the neighborhood of this point, let's say delta x away, I want to understand what has happened to the function. So we have reached the point x plus delta x, and at this point our value will be f of x plus delta x. So what do I mean by that? So what I'm trying to say कि ये आपका function है कि आप अगर आपको value निकालनी, what is the value of y at 1, you will find f of 1. So for example, if the function is, let's say, x square plus 1, so we can find the value at x is equal to 1. We can say value is 1 square plus 2, 1, so it is 2. And if I want to find the value in the neighborhood, let's say x is equal to 2 pe, so which is at one distance away from that, so let's say delta x is 1. So at that point y ka value will be f of x plus delta x, or it will be f of 2, right? So I can put the value 2. So in this case I want to say कि at x plus delta x, value of this function will be f of x plus delta x, and I want to say कि there with this small change in x, there is also some change in y, and I have reached a point y plus delta y. So let's see what I want to do with that. So I want to mark this coordinate as x plus delta x, comma y plus delta y, or x plus delta x, or I want to mark this as x plus delta x, comma f of x plus delta x. So it's just x comma y coordinate, x comma y coordinate. Since our value of x is x plus delta x, so at that point the y coordinate will be f of x plus delta x, because this is the function that we have. And Let's try to find the slope of this line that joins these 2 points. Let's try to find the slope of this point line that joins these 2 points. So first of all, I should mark what is delta x. Delta x is a small change in, let's say, it's a small change in x, and delta y is, it's not small or it's not big. It's relative to x. It's the uh, it it's the simultaneous change in y as we change x, right? So it is change in y. It is the change in y with small change in x. So we change the value of x a little bit, and y can change a large value or a small value or nothing, but it's a change in y. Delta y is change in y with small change in x, So the slope of this line, as we can see, is y2 minus y1 by the last lecture. We can use the definition from the last lecture, by x2 minus x1, and that comes out to be y plus delta y minus y upon x plus delta x minus x. So that is delta y by delta x. That is one way to write it. Or I can use the alternate definition. It is also equal to f of x plus delta x minus fx by x plus delta x, that is the x2, x plus delta x minus x, and here x will cancel, and this is equal to f of x plus delta x minus fx by delta x. Okay, so we have got now, so this slope is, I should be more careful. I should say this is the slope of the secant. Slope of the secant, because as right now this line is cutting the curve at 2 points. You should remember from the chapter circles last year, tangent is a line that touches a curve, secant is a line that cuts that circle at 2 points. So right now it is cutting this curve at 2 points, so it's a secant. But we want to convert the secant into tangent. So what we are going to do, we are going to slide x. So let's see. So what we are going to do, let's say this is our point x and this is delta x. So and this is x plus delta x. So what we are going to do, we are going to we will say let delta x approach 0. We will say let delta x approach 0. So what will happen now, this point will come closer and closer and closer. This tangent, this starts from here, this line will become like this, then finally this, and finally when this point slides right next to this, when it is very very close to this, the line will be passing through 2 points, but let's say it's just touches the curve now. So what will happen is, if we slide that point, if I slide that point, I will get instead of, so let's say these 2 points, so I will get this line which is tangent. Here delta x is much smaller, right? So here let's say this point is much closer on the curve, and this is x plus delta x, and the small change is just this, and this is becoming more and more like a tangent. So this is the limit we need to apply. This is a limit that we need to apply, and that makes slope of the tangent. So let's redefine everything here. So slope of the tangent for that curve, it is same as delta y by delta x, but we have to apply a limit that delta x is tending to 0. So delta x was already small, so it has become infinitely small. So it is very very small now, and it is also equal to limit delta x tending to 0. and this value, right? Because these two are same, right? y2 minus y1 upon x2 minus x1. So it is f of x plus delta x minus fx by delta x. And what we have now basically is actually the first principle. This value here is what we call as dy by dx. This is something what we call as dy by dx, and this is also the slope of the tangent at some point x comma y on the curve, and x comma y should lie on the curve, and this is equal to limit delta x tending to 0 f of x plus delta x minus fx upon delta x. So this is the definition for the differentiation, and this is also called the first principle. So this is also called the first principle. Okay. Now, what do we do with this? So actually in your mathematics course, you will learn more about this, how to use this. But right now we will do 1 or 2 derivations using this formula. Then we create a list and we show you how to differentiate simply. So let's try to find some very important formula. So if we have this function, let's say y is equal to x to the power n, we want to prove that the dy by dx for this function will be n times x to the power n minus 1. So this is going to be the first important formula here, and let's use our definitions. So dy by dx is by definition is equal to limit delta x tending to 0 f of x plus delta x minus fx by delta x. So by definition we know y is equal to fx is the definition of the function. So I can also write that this side as fx. So we know fx is x की power n, correct? So we know fx is x की power n. So what will be fx, तो यहाँ पे हम directly डाल सकते हैं कि this is x की power n, and we have a delta x. What is function का value at x plus delta x? So we'll put x plus delta x here, and we will have x plus delta x to the power n, and the limit is still delta x approaching to 0. Okay, so we had this formula, we put the value of the function, and for this particular function we have this thing here. And now how to handle this? So please remember delta x is very small, right? It is approaching 0, it's very small. And we have learned how to resolve such a power in the previous lectures. We have to use the binomial approximation because this is very small compared to x. So what I can do, maybe I can take x, so we know the binomial approximation for 1 plus x to the power n, it is approximately equal to 1 plus nx if x is very smaller compared to 1. So this is something we know. So but we have a x here, so how to resolve, how to bring a 1 here? We'll take x common, right? So let's see, let's take x common, and what we have is limit, and we have x to the power n common. We have 1 plus delta x by x to the power n minus x to the power n divided by delta x. So in this bracket here, this is 1 plus x plus delta x. So delta x was very small, delta x by x is much smaller, and we can bring n inside, and what we have is, this is limit delta x approaching 0, x to the power n 1 plus n times delta x by x minus x to the power n by delta x. So we brought this n inside, and now we can open the bracket. We have used just this formula, Okay, if we have a 1 plus something and this something is very small, we can bring the n inside, and we open the bracket x to the power n, and यहाँ पे एक x cancel हो जाएगा, we have x की power n minus 1, so we have n times x की power n minus 1 delta x minus x की power n by delta x, and we cancel these two terms. We can divide delta x now. So this was the problem term here, the delta x, and now we can divide that, and what we have is n times x to the power n minus 1, and limit is till delta x approaching to 0, but there is no delta x in the expression, and so answer is n times x to the power n minus 1. This is the value of dy by dx using the first principle. So we have just learned now x to the power n के लिए differentiation is n times x to the power n minus 1. So let's learn some uses for this. So let's see how we can actually use it for different powers. So let's see. So for now, let's say we want to differentiate x square. It is very easy. We write 2 outside and x to the power 2 minus 1, and that is equal to twice of x to the power 1. So twice of x to the power n, and x to the power n minus 1. So let's say we have the function as x की power 1. So x की power 1. So I will have 1 into x की power 0, and that is equal to 1. So we have a formula list being created on the right side. So x square का differentiation is 2x, x का differentiation is 1, and we can write down, we can keep on writing, but I will not write the cube in the list. Cube will be 3x square, right? 3x की power 3 minus 1, 3x square. Okay. Now let's do some important ones also. Let's say our function is, let's say y is equal to root x. So we want to differentiate this. So right now what we can do is, it is x की power half, and we can use the same formula. dy by dx, the differentiation will be half outside, x की power half minus 1, that is 1 by 2, x की power minus half, that is 1 by 2, 1 by x की power half, that is 1 by 2 root x. And we have a formula, root x का differentiation is 1 by 2 root x. Some important formulas for your class 11th. Okay. So we can also do differentiation for, let's say 1 by x. So okay, you will say how do we differentiate this? So actually this is x की power minus 1, right? And we can still use the same formula, dy by dx. So carefully, minus 1 outside, x की power minus 1 में से हम क्या subtract करेंगे? 1. Okay. And we have minus x minus 2, and that is minus 1 by x square. So we have one more important formula in this list, that is 1 by x has a differentiation minus 1 by x square. Now we can actually differentiate now a polynomial also. We can use this formula here, कि if we have y as fx plus gx, so it will be dy by dx will be differentiation of fx, that we can call as f dash x, and differentiation of gx, that is g dash x. Very simple formulation, कि we can differentiate both of them. And we have this one also, differentiation of a times fx is a times f dash x. So constant, if you have a multiplication with a constant, it does not affect the differentiation. We just keep the constant there and we differentiate the function. So we will learn about this in the coming lecture in the multiplication rule also. We will talk about this more, but let's see how to use all this. So let's say I can say I have a function, let's say that is 2x square plus 3x plus 2. Okay. Now we want to differentiate this function. Okay, so I will say dy by dx. So we are actually applying the dx operator on both sides. So I have to differentiate the right side also. So I have ddx of this whole thing actually, right? So we have applied the ddx operator on the both sides. This is the differentiation operator. So 3x plus 2. Now so if I've forgotten to write, so you should also remember कि constant term का differentiation 0 होता है, because the differentiation gives you the slope of the tangent. So if I have a function like y is equal to 2, it's like a constant function, so this will always go at the height 2, and at any point the tangent is parallel. So the differentiation for this function, constant function, so we can you do it with the first principle also. Let's say if I have y is equal to constant, so this is the y is equal to fx, dy by dx by definition is limit delta x tending to 0 f of x plus delta x minus fx by delta x. So please see, this function is always has the value of this is the y is equal to fx, and this function has always the value c, the 2 the height 2 in that example. So I should write here c, because function का value is always c at x or x plus delta x या 2 या फिर infinity, because it is the same answer always, same height, minus c by delta x, and the limit is still not applied, and the c will cancel. We have 0 by delta x, so we have not applied the limit, so that you have to take care. So let's see, we have limit delta x tending to 0, we have 0 by delta x, so answer is become 0. We have not applied the limit, so limit is delta x approaching to 0, 0, and answer is 0, right? Okay, so for a constant function dy by dx is 0, so we please add this to your list. Constant function के लिए differentiation 0 होता है. So let's come back to our example. Let's come back to our example. So what we have is, I can use this property. So first I can use this property. I can have ddx of 2x cube plus ddx of 3x plus ddx of 2. Now I can use this property, and what I will do is bring these numbers 2's and 3's outside. So I have twice ddx of x cube plus 3 times ddx of x plus constant का differentiation is 0. We know that this is just 2, it's a constant, and now we know x cube, x का differentiation, so we can say 2 into 3x square plus 3 into 1, x का differentiation 1, and plus 0, and what we have is 6x square plus 3 as the dy by dx. Now let's see if we can do it faster. So dy by dx हमें क्या करना है, हम 2 लिखेंगे, then we go to the polynomial x cube का differentiation we can do directly also, 3 x की power 3 minus 1, so 2 plus 3, and x का differentiation 1 and plus 0, and we get the same answer, 6x square plus 3. So you can do it faster also. But I just wanted to show these simple formulas. Now there are some formulas that you will need to remember for your class 11th. Some of them we will derive in the coming lectures, but right now I will make a list for you that the formulas that you will require. So some of them I already made, plus in addition to those we also require differentiation of sin x, and that is cos x. So we have a function here and we have the differentiation here. Cos x differentiation is minus sin x e to the power x, which has the differentiation e to the power x, log x log base ex, which has a differentiation of 1 by x. We'll talk about these two also in coming lectures. And we have other four also, the tan x, which has the differentiation of secant square x. We'll talk about the derivations for these, cot x minus cosec square x. And we also have the other two, right? The cosec x and the secant x. Secant x has the derivative of secant x into tan x, and cosec x has a derivative minus cosec x into cot x. So what I can say right now is we will derive these, and maybe this one. So these three, the basic ones, you should refer to your chapter differentiation in your whichever course you do, and this can be discussed in detail, but these we can do in the next lecture. But these will be some basic formulas that you should remember for your class 11th. Thank you for watching. Like, share and subscribe.